Now we're going to move on to vector fields. So with vector fields, you have some sort of vector function that will generate lots of vectors, and collectively these vectors will form a field. So for example, you've got this function here. So let's say you're currently at this location here, 2, 2. So when you're at this location, your x is 2 and your y is also 2. So you would put 2 into the x, 2 into the y, so that will then give you this vector 2 in the I direction and 2 in the j direction. So it would look like this. Hang on. So it would be 2 in the x direction and 2 in the y direction. So you're going to get this vector here. So what that means is if you're currently here, you're going to be pushed in this direction by this amount of magnitude. So it's going to be strong here and then weak here. So for example, if you're currently here, let's just say this is 1, 1, then put this into the x, put this into the y, it will then give you this vector I, 1i plus 1j. So that means 1 in the x direction, 1 in the y direction. So you're going to get this vector here. Notice that this vector here is weaker than this vector. So it depends on where you are in your domain. So for example, another vector function is this thing here. So let's say you're currently at this location here. This location here is 0, 2. So this is your x, this is your y. So put this into the x, put this into the x, put this into the y. So you're going to get minus 2i hat, and then put these two into here. So you're going to get 2 squared and then square root it. So you're going to get 2. So overall it would be 2. So you're going to get minus I overall, I hat. So if you're here, you're going to be minus I hat. So you're going to have this vector here. So let's say you're currently here. So this location, let's just imagine it to be 3 across and 0 up. So put this into the x. So that would be 3 j hat. There is nothing in the y. And when you square the 3 and then you square root it, you're just going to get 3. So if you're currently at this location, you're just going to have a vector where it's 1 up. So it depends on where you are. And then if you plot lots of points, you're going to get this vector field here. So for example, if you want to model, let's say an under ocean deep sea vent, or an underwater volcano, you might want to use something like this. So if you drop, let's say, a shrimp around here, the shrimp will be pushed in this direction. It will be pushed in this direction. Or if you drop a shrimp right here, then it's going to be pushed in this direction. Or maybe you want to understand the airflow of a wind turbine, so you might want to generate something like this. Or you come up with some sort of vector function to describe water flowing through a pipe. So you've got lots of water molecules flowing through a pipe. Because there's a lot of friction between all the molecules near the wall, then there's more friction, so it doesn't move as fast. Whereas if you have molecules in the middle of the pipe, there's less friction, so it flows a lot faster. So you can use some sort of vector function to model water flow through a pipe. Or another example is, say this is Earth here, this is Earth, and this is the moon here. If you were to drop Neil Armstrong somewhere around here, he's going to fall to the moon. If you were to drop Neil Armstrong somewhere here, he's going to fall to the Earth. So a vector a vector field is a collection of vectors that will act upon you depending on where you are within your domain. Okay.